Hello guys, today we are going to discuss a Norton theorem. According to a Norton theorem, any two-terminal linear bilateral DC network can be transformed into a Norton equivalent circuit. So a Norton equivalent circuit is a circuit which consists of Norton current source, which can be represented by IN, and a Norton resistance, which can be represented by Rn. So we have the following steps which need to be followed to convert this network into a Norton equivalent circuit. So in the first step, we will remove the RL resistance for temporary basis. So the RL resistance must be removed for temporary basis. So our circuit will look like this. Now our circuit will look like this. Now in the second step, we are going to find the Rn resistance, which is the Norton resistance. So for the Norton resistance, the voltage source should be replaced by a short circuit. So our circuit will look like this. So this is the circuit. So in this circuit, if we look into this side, the R1 and R2 resistance are actually parallel to each other. When we start flow the current, so the current will split into two parts. So according to this phenomena, these two resistance are actually parallel to each other. So let's find the Rn resistance. So R1 is actually parallel to R2. So 3 ohm resistance is actually parallel to 6 ohm resistance. So now 3 cross 6, 18 divided by 2, which is equal to 2 ohm. Now Rn resistance is actually equal to 2 ohm. So to find the IN current, we should follow the following steps. So to find the IN current, we will return the voltage source, and the two terminal must be short circuit. The two terminal must be short circuit. Now as we know that zero amount of current will flow across this resistance, so we will neglect this resistance. Now for IN, what we are going to do, for IN we should left with a resistance R1 and a potential of 9 volt. So IN can be easily find through this procedure, so which is equal to 3 ampere. Now we found IN and Rn of the Norton equivalent circuit. So our Norton equivalent circuit will look like this. Now a Norton equivalent circuit will look like this. A voltage, a current source of 3 ampere and a resistance of 2 ohm and a current IN, current source of 3 ampere. So this is the end of the lecture, and we will discuss Norton theorem, some complicated equation or some complicated network. So we will discuss later some complicated network, and we will solve that network through Norton theorem. Thank you for watching.